So it's the seed we can use
Just
now to
don't
create
give up.
other databases that are attached to this container database. Or we can even create other databases from this seed and attach it to another container database. Then we have a CDB, container database administrator, that's managing the container database right here. Then we can also have a PDB administrator. For example, what we have here, we have CDB, we have this container database, we have the root container that's there, to which is attached what? The seed PDB, the seed pluggable database. And then we have other databases attached to it. We have HR PDB. And then we have sales PDB with respect to those services. We have HRL. So now we have this CDB administrator. Now, who manages the entire container with the pluggable databases. He has power to manage all the databases that are in this container. Now we have the administrator for HRPDB. He will only be managing this database, that pluggable database, that HRPDB pluggable database. And then we also have the PDB administrator for sales PDB. He's only managing the sales pluggable database. So as Riley portrayed here, illustrated, we've got the sales for sales application, that's the sales PDB, and HR application for the HR PDB. Then we've got also the logical and physical files. As far as this container is concerned, so we've got the data files, the control files, the online blue log files, the archive blue log files, and the flash backlogs. They are all based in the container database. Now let's just get back to the important points, even in case you have any questions. There's one database, that's the CDB. There's one database instance with one system global area and one set of background processes. What does that imply? That simply implies that in order to access other databases that are attached to the CDB or in that container, you have to go through the CDB in order to access those databases. A PDB is nothing more than a set of table spaces and a service. The PDB services are exposed to users by the database listener. So each pluggable database is expected to have a listener. Now, when you connect to a PDB service, the scope of your session is limited to the table spaces associated with the PDB. So you can have a PDB and simply your session is limited to the table spaces associated to the PDB. So from the architecture that we saw earlier, so we can have different DBAs that are assigned to the various PDBs, pluggable databases. So when you connect to a PDB service, the scope of your session is limited to the table space associated with the PDB. Objects defined in the root container may be shared or visible to all PDBs. That word may be. I'm sure I should put it in caps lock. May be shared. It's just a possibility. And visible to all the PDBs. Objects including users defined in a PDB are private to their PDB. For example, what we'll be having, we have BTDEV, we have Class T. Normally, if we're having a PDB that is a container database that's 12C or 19C, all the pluggable databases that are associated to it should be 12C, they should be 19C. We'll not expect to have an 11G that's attached to a container database that's 19C. We'll also expect that if it's a 12C container database, all the pluggable databases that are attached to that container database, they should all be 12C. They will not have a different version of the Oracle database. So what we are saying is that objects defined that container, that is the container database, may be shared. So there are possibilities where we'll discover that we might have table spaces that are found in the container database that can also be found in the pluggable database. But those pluggable databases that we should have, what thing we should have in mind is that those pluggable databases, they are just like standalone databases. They can be managed differently. They're just databases that can be assigned to different services. And we have different DBAs that are being assigned to manage those pluggable databases. But the CDB database administrator can manage any, has powers to manage any of, can access any of those pluggable databases. So objects including users defined in PDB are private to their PDB. That's just what I was saying. Each PDB has its own data dictionary defining its local objects with pointers to shared objects defined in the root container data dictionary. So the PDB has its own data dictionary, but has pointers to shared objects defined in the root container. So the PDB is simply a derivative of the container. It's a derivative of the container, but can have its unique. So can have different PDBs having with different objects. Sorry, next slide. Are we here? Oracle multi-tenant architecture. Or next slide. And Oracle, just like as we're saying here, we have CDB, we have the CDB administrator, the root container, that's there, CDB root, then the seed, which is PDB seed. This is a default. So each time we create a container database, this PDB seed is also created by default. They'll have the HR PDB and they'll have the sales PDB for sales application and HR application respectively. And then they can also have the PDB administrator for HR PDB for the database and the PDB administrator for the sales PDB. Oracle multi-tenant architecture. An Oracle multi-tenant environment consists of a container database, CDB, and one or more pluggable databases, PDBs. A container is simply a set of table spaces exposed to the wall as a logical database. So, as I was saying, on creation, a CDB will contain a minimum of 2 containers. The root container, named the CDB root, is the management container for the environment. Generally speaking, no other than the DBA will ever connect to the root container. The seed container, named PDB seed, is a supplied read-only container that can be cloned to create pluggable containers. That is, other pluggable databases. If we want to create other environments that have to be linked to that CDB, we can use that CDB, that PDB, and clone it. And there are several methods of duplicating a database. We can either use ARMA, we can use the most recent method is DataPump. We can use that method also to duplicate a database. We can create other databases. Now let's move on to the next slide. Any questions, please? Do we have any questions?
No.
Okay. So, considerations when using the Oracle multi-tenant. All containers must use the same character set. This is a natural limitation of the fact that there's only one database, the CDB. Then DataGuard, we'll also look at that. DataGuard must be configured at the CDB level because there's only one stream of redo logs. It is, however, possible to exclude some PDBs from standby databases. Note that this is possible only from the release 12.1.0.2. However, high level. DataGuard, we'll look at that later on. DataGuard is simply a standby database for disaster recovery circumstances, high availability, and maximum performance. Then we've also got Data Vault. Data Vault for security must be configured individually in each PDB. Data Vault is used for security implementation. There is no overlap of regimes across PDBs, so it can be configured independently. So the various PDBs can simply configure their various security protocols that will be different from what is found in in the other. So we should not expect that what is found in PDB, HR PDB will have the same configuration in sales PDB. They can be configured separately. So what we should always have in mind is that those PDBs can be different environments, different databases that are managed differently. Encryption must be configured individually for a PDB. Each PDB generates and manages its own keys stored in a shared wallet. So we're still talking with respect to configuration, because encryption is one of the methods in which we can encrypt our sensitive data. So you can use it separately. You can use different methods to encrypt sensitive data. Unified audit can be configured at the CDB level. That is point 4. We are here. Unified audit can be configured at the CDB and PDB levels. That is, unified audit is also one of the methods of auditing at the level of in a multi-tenant container database. Most of the time is used to audit roles and users. I mean, in case they misuse the privileges that are being given to the various users. So when they have unified auditing, it will audit the roles and the users. And obviously, the report should expect the report in the audit trail. So what unified audit can be configured at the CDB and PDB levels. So when creating a policy in the root container, appending container equals all to the create audit policy command will propagate it to all the PDBs. So this command is very important. Container equals all. So if we have to use that container equals all, it will be propagated to all the PDBs concerned. As I said earlier, a PDB can lodge roughly more than 200 databases. So in a PDB, any policies created are local to the PDB. Then we have Golden Gate and Extreme Replication are multi-tenant aware. They can capture and apply changes per PDB as well. Golden Gate is also a replication tool. It's also used for data transfer. And we can use Golden Gate in different platforms. We can use Golden Gate in different platforms. That's the unique identity with Golden Gate. We shall see that later in our lectures. Then multi-tenant single tenancy, CDB with a single PDB. It's not abnormal. With just a single PDB. That's talking about single tenancy. If we want to talk about tenancy, we're talking with respect to the number of pluggable databases that are attached to the container database. The reason is that while some sites may not need the server consolidation features of Oracle multi-tenant, all sites face problems of downtime because of patching and upgrade that can be alleviated in an Oracle multi-tenant environment. Patches need to be applied to the root container only. The pluggable container does not need to be patched. Now, what are we saying? We are saying that, for example, patching. What is patching? I mean, a patch is simply making up for a bug. If in case we have a bug, how do we fix a bug? Obviously, Oracle always sends out patches to make up for bugs, based on the reports that are coming from users. We have bugs for the sake of security. Then it's also a means to reinforce the software that we're using, the software and database, the version that we're using. So when they have to create a database version, there might be a bug, or there might be insufficiency, there might be performance issues. So they just send out patches, and these patches are released 4 times a year, 4 times and quarterly. I think those patches are released in January, April, July, and October. So those patches, and for standalone database, for example, if we have a container database that's made up of 100 databases, pluggable databases. Now, what happens with those patches? They will be applied at the level of the container database, and when they are applied at the level of the container database, it will take care of all the pluggable databases that are in that container. Now, but we stand alone. What happens? Each patch is simply applied to the standalone database. For example, if we have Class T and BTDEV, those patches will simply be applied to Class T or BTDEV, unlike with container databases, in which case you have to single out each database and apply the patch. But with container database, you simply apply the patch at the level of the container. That is the CDB root container, and it will take care of all the pluggable databases if we have 200 databases in that container. That's simply what they're saying. Now, some set of views over there here. Yeah, set of views as far as the container database is concerned, or the environment. Now, we've already seen this before. In non-CDB environment, we've got user underscore. That is, those are all objects owned by the user who is querying them. For example, in a schema, this is the view that we usually use in a schema. User underscore. We could have user underscore objects. We could have user underscore tables. We could have user underscore maybe control files or data files. Now we have all. We've seen this also. All underscore. That's also a view. All objects on which the user has privileges, regardless of the schema in which they reside. Then we also send DBA underscore. We could have table, DB underscore tables. So this shows all objects, shows all objects in the database. So we use DBA underscore tables to show us all the tables in the database. Or DB underscore table spaces will show all the table spaces in the database. If we have to use all underscore table spaces or all underscore tables, it will simply show us all the tables that a particular user has privileges to access. And for the user underscore tables, we simply have all the tables owned by the user that's querying them. Then for CDB underscore, it shows all objects in the CDB, in the container database, union of all the DBA views in every container. The container here is the PDB. So when we're using CDB, view with CDB underscore, it will simply show us all the DBA views in every container, because we expect a DBA to manage each pluggable database. So the CDB view will simply show us, it will be a union of all the DBA views in every container. That's the PDB, namely the root container, the seed container, and all pluggable containers. And then we can use con underscore ID. That identifies the containers from which the row came. Now let me just share my screen. There's something I wanted to say here. I wanted to point out here. Yeah, let me come here. Boom. Look at those queries. Now, the drivers for multi-tenant. This is what should be taken note of. How is the multi-tenant environment different from the standalone? Now, it says creating one CDB and running each database as a pluggable container will yield savings. You have only one set of background processes. We saw that earlier. One SGA, which usually be much smaller than the total of the individual SGAs. So just imagine if we had 100 databases, and each of those standalone we should also expect 100 SGAs. That is system global area. And so if we have to manage that, and then with the container, even if you have 100 pluggable databases, we'll simply have one SGA and a single set of background processes, which will usually be much smaller than the total of the individual SGAs. That's what I'm saying. So it simply consolidates. It's also economizing. It's less costly for the company. One copy of many data dictionary structures and one Oracle home. So we've got a single Oracle home in the container in the CDB root. The CDB architecture enables sharing of these resources with consequent savings, as expressed earlier. Now we have the CDB and the root container. So if I talk about the CDB and the root container, we have to come back to this architecture. We'll talk about the CDB. This is the CDB root, the root container. to which we will now have pluggable database that have to be attached to the container, the root container. So I was saying that we can have as many as more than 100 PDBs. So if we look at the CDB and the root container, the CDB is a database mounted and opened by the instance. The root container is a container from which all the shared resources are managed. Principal among these are, we have the control file. We've got the control file. We've got the undo table space. We've got the redo lock. We've got the instance SG and background processes, as stated earlier. And then we've got the data dictionary, and then common users and roles. What do we mean by these common users and roles? We mean common users that can access any of those pluggable databases. Then, if we look at the root container, I said earlier, so we're talking about the control file is based in the root container. The undo table space, the redo locks, the redo lock files. We've got the instance SGA and the background processes, the data dictionary, the common users and roles. Then as far as the root container is concerned, we've got the system, the sysO, the undo, and the temporal table spaces with the common users and roles that are propagated to all the pluggable databases. And it will have all the Oracle supplied objects that every PDB requires. Any question, please? Or is there somebody there who has something to add?
Yeah, I need to ask you a question.
Okay.
Thank you. My question is, isn't the CBD the same thing as the root container?
The CDB?
Yeah, the container database.
Okay. Now, let's have a look at this. Now, they will have the CDB, right?
Yes.
The CDB has the root container and the pluggable databases.
Okay.
Yes. Because in the CDB, we're saying that the container database has in the container, we have what? The CDB root container that's attached to which we have these pluggables attached to it.
Oh, okay.
So when I talk about the container database, we're talking about all the CDB and all the what? The pluggable databases.
Okay.
Yeah.
So the CDB root is like a conduit for other pluggables.
Yeah, it's like a model container, right? The CDB root, like a model container that gives rise to what? That has to take care of all the pluggable databases.
Okay. So the PDB seed is like the default.
It's the default.
Yes, for the CDB root.
It's like a default pluggable in the CDB root. So when you create a CDB root or the CDB container, the CDB root and a default PDB root.
Okay.
Yes, by default.
Yeah. Thank you.
So when we are creating, for example, if we have to create and say we are creating did people say you already installed 19C?
Yes, we have.
Yes, we did.
Did you install it as a multi-tenant, as a container database?
No.
Okay. Now, when you're installing as a container database, maybe you might be required, if you don't want to add, if you don't want to attach a pluggable database, you don't want to create a pluggable database, because when you're creating a pluggable database, it will be an additional database pluggable to the seed, the PDB seed. It will be additional to the PDB seed. Okay. Any other questions, please? Now, so we are at this level. So we're saying that at the level of the CDB and the root container, we have the root container, we have all these files. We have the control file, the undo table space, the do log files, the instance AG and the background processes, the data dictionary. Normally the data dictionary is made up of the metadata, data about data, the common users and roles. And then we've got the root container. The root container contains what? The system, sys undo, and temporal table spaces with the common users and roles that are propagated to all the PDBs, and it will have all the Oracle supplied objects that every PDB requires. So we can we can connect to the root container, but we're somewhere here. I came back. There was something I wanted to yeah, that's where we were. Okay, now, so just for the sake of illustration, let me move my over X here. Okay, so this is what we created. CDB1, right? That's what we created in CDB1. So if I type select name open mode from $, database. That's the CDB. That's the container database that we created. That's CDB1. And then I can also select name open mode from $BDBS. We'll have, if you look at this select statement, here we've got select name open mode from $, database. So we're having CDB1, that's our container database. It's in read-write mode. So it's open, that's open mode. Then I've done a select name open mode from $, PDB. So we've got open mode. You look at, we have PDB seed. We've got a PDB seed. Then we've got PDB1. Then we've got CDB1 class B. Maybe let me place it. Let me just arrange. We've got colon name format A20, and then we've got select. Just so we can probably have a look at this in this manner. So we've got the select name open mode from $, PDB. So we've got the PDB seed is by default created with the container database. Then other pluggable database that we created, we've got PDB1, CDB1 class B, we've got CDB, that's CLSP, they've got CDB1 class P. So those are some of the pluggable databases that we created that are attached to this container database. Now, we can simply type show con name that gives us the name of the container. We also type show.
Is that the container root?
Yes, that's the container. That's the root. That's the container root. CDB root. ID. That gives us 1 because the CDB root is always having an ID of 1. It's always having an ID of 1 by default. So we have the show container name. But we can always, as we said earlier, we can always access the pluggables from the container. We can simply alter session set container For example, equals PDB. We got one of the one. Want to access the pluggable database PDB1. So simply use the simply query alter session set container equals PDB1, semicolon. So if we have to show on name, what do we have there? We have PDB1.
Okay. I have a question there. What you did alter from where? From the CDB root?
From the CDB root.
Okay, so you alter it as what when you say alter set container?
We want to alter the session. We want to change. We want to access PDB1. We want to access PDB1. So when you want to access, because by default, when you log into the database, into the container database, you are in the container in the CDB root.
Okay.
Yes, you are in the container CDB root. So when you're in the CDB root, when you want to now access any of the pluggable database, you now use the query alter session set container, the container you wish to access. We can equally access alter.
Okay, that would give you access to that PDB directly.
Yes.
Okay.
So we can simply have alter session set B CDB class P semicolon, then show on underscore name semicolon. That's what we're having.
Okay.
So that's so you should have that in mind. Whenever you want to access any of the pluggables, you simply use alter session set container equals. In order to confirm that, you simply you continue with show con underscore name.
Container name.
Yes.
Yes. Okay.
So now we are now working. If we want to, we are now in CDB1 class P. So we can now query, like for example, if we want to get the tables in CDB1 class P, we have describe all underscore tables, for example. So we can now query, we can get the tables, or we can now have select. Normally, if we have to look at that, what we have here, select statement. We have table name. Let's say we can have the table name. Got table name there. Also got table space name. From so we have roughly 2,178 rows selected. Now, remember when we are using all, show user. We are 6. We could equally have used describe DBA underscore tables. We could equally have used DBA underscore tables. Remember, as we said earlier, when we are using user underscore views, that you're accessing objects that the user owns,
and the one he has access to.
When you're using all, you're accessing the objects that he has access. That includes the one the user owns. And then when you're using DBA underscore views, that will give us access to all the objects that are within that the DBA has access. So that will involve all the users as well. So as far as that is concerned, if we're using, let's just select, we have table, is that what we use? Let me go back to the query we had earlier. That's taking us too far. We've got select table underscore name from DBA underscore there's no select, sorry. Select so that gives us all the tables that the DBA has access in CDB1 class P container. CDB1 class P container. So those are all the tables that the DBA has access in that class P container. So those tables, we don't expect those tables to be the same in the various PDBs. Now we can carry on. So most of the time, what is very important to you that we should know that this query, alter session, seemingly slow, alter session set container equals, for example, PDB1. Should be very important. Is show con underscore name. Those are very important queries that we should always have in mind when we're dealing with the multi-tenant environment, because that gives us the room to access any pluggable database in the container.
One question there, if you don't mind. So to go back to the CBD root, all you have to do is alter container to that place you want to go.
Alter session now. What do you have? Yeah, alter why is it slow? Session set container equals, what's our container database? CDB1, right?
CDB1,
right?
It says it doesn't exist.
Yes. So, however, we can simply exit, right?
Okay.
We can simply exit, and then
go back in.
Yeah.
It will take you to the default.
Yeah.
Thank you.
To take us back to the default. So here is the show container. On. So we have CDB underscore root. I think what we should have, what we probably should have used CDB dollar root. I'm sure that's what we would have used. Would have used CDB alter session set CDB dollar root, because CDB1 contains CDB root and all the pluggable databases. I hope that's understood. Hello?
Yes, I got it. Thank you.
Yes, I was saying that when you want to alter, for example, this what we used here, just 1 second, if we're having alter session set PDB, that's something. Then we have show container con name. That's what we're having.
Mm-hmm.
Then we have to use alter.
You have to get the real right name.
Yeah. Then let's use this. Now it's altered. So if we use show one name, now we have CDB root.
Okay.
Yeah, so that's how we can access it. Thank you very much. That's a wonderful. Most of the times, I usually go back and then try to access the container. So I've never really thought of using this method. I mean, thanks so much. Okay, now let's get back. I think now we're able to first of all have an idea what a multi-tenant architecture is all about. Multi-tenant container architecture is all about. That we got a CDB root, we got pluggable databases. First of all, have a default PDB seed. We have a default PDB seed, and then we've got other pluggables that can be created from the PDB seed. And there are several methods that we can do that. We have, first of all, one of the methods that we know already is Datapump. We can simply clone as well or use RMAN, Recovery Manager, to duplicate a PDB seed. We shall look at that. Now, any other questions as far as that is concerned? And then one of the most important things to also retain is that what? The control file, unlike what we saw earlier, the control file, like in standalone, each standalone has its own control file, to-do logs, SGA, and background processes. But with the container database, we've got the control file, the do log files, that's the SGA and the background processes, the data dictionary, and the common users and roles are all found in the CDB root. They're all found in the CDB root. So it's like so those common users and roles can easily access the pluggable databases. But notwithstanding, each pluggable database can have its own users, unique users and roles. Now, how do we expect to look at the multi-tenant container in our organizational structure? It's just like in a situation where we have maybe we are DBAs, you have junior DBAs to which are assigned pluggable databases to manage, right? Then we've got a senior DBA that's seated who is out there supervising our work in the various the databases. That's how the multi-tenant architecture looks like with Oracle. So that you have that container with so many pluggable databases, which can take up to 250 databases, and the common user there in the CDB role is overseeing all the activities that are taking place in all the databases. Patching is done at the level of the container database. We have a single control file. We've got a single control file. We've got the undo table spaces. We've got the log files in the CDB role, and then we've got the SGA and the background processes, and data dictionary as well. So we saw this already. And then here, okay, we'll talk about pluggable databases. That's our next slide. That's where we are now. We'll just talk about pluggable databases. So we're saying that pluggable databases are like standalone databases. So a pluggable database container, also referred to as a pluggable database, simply a set of table spaces and objects to be used by developers and end users as though it were an independent database. So some of those object names that we can use as far as in those environments. Every pluggable database has a unique container ID number. For example, did we have a look at this? Let's look at that of this is we had this. Let's look at the ID of this that session. Then we have show on underscore ID. So the ID there is 3. So each pluggable has a unique ID in the CDB. So every pluggable has a unique container ID number and container name. These are recorded in the control file and exposed through the views $containers and $PDBs. Remember, that's what I used in order to determine the name and number of pluggable databases in the container. So we've got each PDB has a unique global name, as said earlier, name of the container, and it's used as a default service to be registered with a DB listener using the EX Connect syntax. As I said, if we are looking at each of those PDBs as like standalone in a container database, that implies that we should expect that each PDB should also have, we should have a TSN names for the PDB. We should be able to configure the TSN names, the listeners in our TSN names, so that we can be able to access those PDBs separately. So they should all be configured in a TNS names, the ORA file. Now we saw that already. Now, in order to connect, this is an example that we have in our textbooks. In order to connect, we can connect directly into our pluggable from the OS level. We can simply connect SQL Plus. We have that connect string system/Oracle at this. This should be at the OS level. What should be having there? We should be having SQL Plus. That's what should be having there. As sys DBA. Then so we have that should be the username. That is the password, and then that's the IP address or the instance. Then we've got the port as usual, and then the pluggable. The pluggable then can be GW. In our case, we can have, it should be PDB. It can be PDB1, what we said earlier. PDB1. You can use PDB1. That's what we said earlier. So we've got the instance and the port. They'll also select, let me just run this query. Select instance. We have instance name from VDola instance. Normally, when we are using this most of the times to determine whether our database is open, whether it's up and running, we can always use this even in the mount or no mount stage. Then we'll have union or select database. Add this from our books. Let me just run this and see the output. Database. I hope we are now in the container. Should have get back to the container. Container. Then let me get back to our. I don't have any syntax error. Okay. Here's an error. Select instance. We should be having error here. Where is that error? 3. However, it's right there in our books. I'm just trying to see whether I can run it. That should give us the container and the various pluggable databases in our environment. So let's just get back here. So alter session set, that is to access. Okay, here we are. In order to access, to get back to our root container, we have alter session set container equals cdb $root. There's a main column. Then we can always select con_id name from $. They should be able to give us something. That's yeah. So when we're selecting the con_id name from $. Container, so we have the let me arrange in order of colon con_id format. A10, then call name format A20. Then we'll go ahead, they'll run this query again. I think it's better. We've got the con ID. We're supposed to have maybe 1, 2, 3. Let me try to check and see what's happening. Let's just change the parameters while we have in the A30. They'll have this. No, but come on. Why do we have this? However, if you look at what we had previously, the con ID, we've got 1, we've got 2, we've got 3, right? 1 is the CDB root container, 2 is the PDB seed, and then PDB 1 is the third pluggable. So they have various. I think those con IDs. We have those con IDs as those pluggable databases are created. As they are created, they are given the container IDs. So if we have to create a new pluggable, we'll have, that should be, the con ID now will be equal to 6. Okay, that's that. Any questions as far as this is concerned? Any questions, please? Hello?
Yeah, we are listening.
Okay. It's good to at least hear your voice, right?
That's true.
No question from me.
Yes, I think we are trying to talk, but you were muted. Okay, now, techniques for provisioning pluggable containers or pluggable databases. PDBs can be created, copied, and relocated, process known as provisioning. So if we have to create a PDB, we are provisioning a PDB, and there are several methods. There are 4 techniques for provisioning a container or a PDB. We can create a new PDB from the seed container, what we saw earlier. This method creates a new PDB consisting of nothing more than the system, sys0, and temp table spaces. This would typically be used for a new application implementation. Now let's get back to where we were. Where are we? We are in show container. Show con name. Are we there? Okay, now we're in the root. So let's just select table space underscore name from DBA underscore table spaces. That's happening. Okay, there was an omission. Select space underscore name, then from DBA underscore. Okay, so you saw that we have in the container database we got system, sys0, undo, temporal table space, and users. This is what is common in all the container databases. This BT data, BT index, that was created later, but by default, we usually have the system, sys0, undo table space, and the temporal table space. Now let's access our any of the pluggables and see and check on the tablespace that I found. Let's access PDB1. PDB1. Show con name. To be sure that we are in PDB1. Then we simply run this query. There we are. DB. Now let's use, okay, we're not using that. Let's now use select or underscore table spaces. Come on. Let's see, we'll have select table space name from user underscore. This is strange.
I think
not open.
I think
Sorry.
the database is actually
Let's
closed.
see, alter session set. So we have, let me see, select name or open mode from $PDBS. So alter blockable. Now remember, it's no longer alter. We're not altering a database. We're not altering a pluggable database. Since the pluggable database, alter pluggable database. Alter pluggable database. PDB1. Open. Now it's been opened. I didn't look at this. I was wondering. Then let's now check the. So we can now run this query. So you saw that by default we're having system, sysO, undo, temp, and users. That's by default. We expect those table spaces. So whenever we are creating a pluggable database, we should expect these table spaces by default. So we now have create. So that was one of the possibilities. So we can create a new PDB from the seed container. That's PDB seed. We can also create a new PDB from a non-CDB. CDB. This method takes an existing database which must be released 12.x. 12.x, in which case we're not talking about maybe class T. We're thinking about BTDEV. Converts it into a pluggable container and plugs it into a container database. This would typically be part of a consolidation exercise. It is not possible to convert back to non-CDB. That's point 3. That we can't convert it to be a pluggable, and then maybe we'll convert a pluggable to a non-pluggable. That's not possible. We can also clone a PDB to another new PDB. The source can be a PDB in the same or a different CDB. So in our architecture here, if we look at the architecture we're having here, we could have, this could be CDB date, we could have another CDB here. So we can simply clone a database from, we could have maybe, we have a CDB1. So we have CDB and CDB1. So we can simply create or clone or create database from one container database to another. That's possible. So we can move the databases. We can also unplug. That is like, it's called unplugging. So we can plug and unplug and take it to another container database. Let's move downwards. This is where we are. Provisioning. Okay. So this is where we are. Now clone a PDB to another new PDB. The source can be a PDB in the same or a different CDB. This could be used for creating test or development environments from a production PDB. We can also plug in an unplugged PDB. A PDB can be unplugged from one CDB and then plugged into the same or a different CDB. That is, in this case, it will just be an issue of changing positions. We can pick up PDB1. We can pick up PDB1 if we are having this infrastructure here or architecture. We can pick up HRPDB and change the position. Immediately we change the position, we can give it a new con ID, container ID. So simply plug it from here and attach it to another position in this CDB, or we can simply unplug it and plug it to another container database. Could be CDB1. That's what they're simply saying. So we plug in and unplug PDB. A PDB can be unplugged from one CDB and then plugged into the same or a different CDB. This can be used to relocate or to upgrade a PDB. That's one of the reasons of carrying out that. Now, communications between containers. We've seen this before. We're using a database link. The objects in two PDBs reside within the same container, so it's possible to create a fast version of a database link known as fast intra-CDB link. Intra means within the container. Within the container. Fast intra-CDB link. Within the container. So we've seen earlier, select con ID, name, domain, and some of those queries. So in our last slide, so they know 2-minute drill as usual. 2-minute drill as usual, which is describing the multi-tenant container database architecture. And any questions before we look at the last minute drill?
Yes, please.
Yeah.
My question is, so you can never convert a PDB to a container database?
No, we talk about converting a non-container database
to a container database.
No, we can. We can convert a non-container database to a pluggable database, but we can't convert a pluggable database to a non-container database.
Okay.
Yeah.
Thank you.
Any other questions? So, the 2-minute drill, normally at the end of the chapter, describe the multi-tenant container database architecture. The Oracle multi-tenant architecture helps us to use server resources more efficiently by sharing instance, memory, and processes, as well as system, tablespace, common objects. Upgrading a multi-tenant container database upgrades all PDBs within the container, just like what I said earlier.
I'm sorry, I didn't get that. I'm sorry to cut you short. I just wanted to make sure that I get what you're saying. You can convert a standalone to a pluggable.
Yes.
But you cannot convert it back to a standalone.
Yes.
All right, thank you.
In which case we're having class T, so we can convert class T to be a pluggable, right?
A BTDEV, because class T is 11.
Class T is 11, a standalone, or BTDEV. We cannot convert a standalone like BTDEV to be a pluggable, right? Because
you cannot convert it back to a standalone.
Yes, you can convert it to a pluggable, but you can't convert it back to a standalone.
Okay, thank you.
Yes, because a standalone is simply a database that's simply managed on its own, right? So we're saying that a multi-tenant container is simply made up of several standalones, so to say. Is that okay? There are standalones, and these standalones, that's what we're calling pluggable databases, and they are attached to a single container.
Okay.
Yeah.
Thanks.
Yeah. So in the second point, just like the 2 minute drill, a summary of what we've seen already. So upgrading a multi-tenant container database simply upgrades all pluggable databases within the container, just like what we're saying. Patching is simply taking care of bugs, maybe making up for certain inefficiencies or problems that have been presented by users. So Oracle takes advantage to prepare maybe patches to make up for those inefficiencies so that it can be more proficient. Now, the third point, a CDB at any point in time can contain 0, 1, up to 252 user-defined PDBs. That's what we're saying, that a container database can have more than 250 pluggable databases attached to it. So a CDB is a single instance, regardless of the number of pluggable databases within the CDB. What does that imply? It simply means that for us to access a pluggable database, we have to, first of all, access the container database, and we can now eventually access the pluggable database. Across all PDBs within a CDB, the do log files, undo tablespace, control files, and temporary tablespace are shared. We saw that earlier, that these files are all based in the CDB root container. An individual PDB may have its own temporary table space. That's a possibility. And then each PDB has its own system table space with private metadata. The system table space has pointers to common Oracle metadata stored in system table space within the CDB. The data dictionary views prefix with DBA underscore have corresponding views with the CDB underscore prefix when queries are run in the root container. These show the entire environment. Now, pluggable database provisioning. The CDB is initially provisioned with the root container, CDB root, and the seed container, PDB seed. As I said earlier, whenever we create a container database, like CDB root, there's a default PDB seed from which we can now create other pluggables. You can clone other pluggables with various methods using the recovery manager or data pump. We've seen that before. Then, secondly, PDBs can be created from this seed container by cloning an existing PDB, by plugging in a non-CDB container database, or by plugging in a previously unplugged PDB. So, thirdly, non-CDBs can be converted to a PDB only once they have been upgraded to Oracle Database 12c. This process cannot be reversed. So what do we expect? So we expect that our PDB should be of version 12c dot. We can't have 11g. We can't have Classic cannot be pluggable. Table data can be shared between PDBs within a container database by using an intra-CDB link, within the container. An intra-CDB link behaves just like a pre-12c database link and requires no application changes. So that's a summary of virtually what we have in chapter 31.
Okay, can you?
I have a quick question.
Yeah.
So with the CDB database, can they actually contain a 12C and a 19C?
Within the same container, no.
Okay, so it normally contain, like, if it's 12, it's just 12.
It's just 12.
And okay.
Yes.
Because I was just confused, like, if it's pluggable, and let's say in our situation we have a 12 in it and we have a 19 in it, how is the patching going to actually happen when you're doing a security patch?
I see.
That's why I'm asking that.
Yeah, so when you look at the pluggable, they are saying that the versions that can be used for container databases, right? The versions, we should have at least a 12 dot for it to be a container. That's the way Oracle has made it. I hope that's understood.
Yes.
So we should expect from 12C.
Mhm.
So we can create a container database from 12C. Eventually, they will have 19C, 21C. Eventually, when we look at when we're seeing what's happening in the cloud, we discover in the cloud, all what we have in the cloud are container databases.
Okay.
Yes, all what we'll be dealing with in cloud, Oracle Cloud, whatever, what they're offering in the cloud are container databases.
Okay.
Yeah.
Okay. Thank you.
Any other questions, please?
I was going to ask that you explain the link for them to share information. Again, go over that point again. The last point on the.
Okay, intralink.
Yes.
Okay, intralink.
Thank you.
Yeah. Intralink. Okay, we talked about it somewhere here. A fast intralink, right? CDB link. Yes, so remember we've had occasion of creating a database link. That is, you can create a database link to communicate between databases. A database link.
Yes.
Now, why are they calling it intra CDB link? It's intra because it is within the same container.
Okay.
Yes, it's within the same container. If we just had a situation where we had just standalone databases, it would just be a database link. But now they're talking about intra. Intra means intra CDB. That is within the same container.
Okay.
Yes.
So it will act as a database link.
Yes, a database link that you can communicate. You can easily access objects in another PDB from another PDB.
Okay.
So if you are in PDB, for example, PDB1, you can access objects in, for example, CDB1 class P from the
PDB1.
PDB1.
Yes.
We'll create a link. Yeah. Any other questions, please? If there are no other questions, points just to remember. Points just to remember. We have the architecture here. First of all, we've got the container database. In the container database, we have a container database administrator. Within this container database, we've got the CDB root container, which gives room to the PDB seed, which is by default created when we are creating a container database. And then from the PDB seed, we can create other pluggable databases. That's one possibility. Remember, also in the course of creating a pluggable database, you can also create a pluggable database. From those pluggable databases, you can clone, you can create other pluggables. Now, we can have up to 252 pluggables within the same container. That should be known. Then within the container, we have what? We have our control. So each pluggable database can have its own PDB administrator.